I think one of the things about metaculture is that it's very engineering empowered. If you can get engineers to support something from the ground up, you can go a long way. And there's a popular phrase, code wins argument. And I think in this case, it's a case of like proof wins argument.
One of the questions that I often ask when I talk to people about spec-driven development is, at what level are we talking about? So what we took was defining a process using Ripper 5, how we're going to work with the LLM, starting with the spec, and then we pair developers with that process.
There's a Stanford research on over 100,000 employees. What they found out is AI is helping generate 30 to 4% more code than before. However, 15 to 25% of that code ends up being junk that gets reworked, right? So they estimated the actual productivity gain is like 15 to 20%. I would think it's higher if you're using AI in the right way.
All large tech companies have this issue. Your software that's been in existence for more than a few years, using legacy that no longer resemble the way that you would rebuild those things today. So we're talking about shifting to architecture with a semantic layer and a kind of a query engine on top to serve the same kinds of metrics queries, but on a off-production architecture.
Before we jump into this episode, I wanted to let you know that this podcast is for developers building with AI at the core. So whether that's exploring the latest tools, the workflows, or the best practices, this podcast's for you. A really quick ask, 90% of people who are listening to this haven't yet subscribed. So if this content has helped you build smarter, hit that subscribe button and maybe a like. All right, back to the episode.
Hello and welcome to another episode of the AI Native Dev. We're here live from New York at QCon AI. And on my journey here, I'm going to be talking with a number of different folks throughout the conference based on whether I think it's a really nailed-on presentation for our listeners. And today's, I absolutely found one. And so this is Sepehr Khosravi, who gave a session choosing your AI co-pilot, maximizing developer productivity. And that is such a cool topic. And you actually mentioned a huge ton of different productivity hacks and things like that in and around using various agents and LLMs. First of all, Sepehr, talk to us a little bit about who you are. You work for Coinbase. What do you do there? And tell us a little bit about it.
Yeah, I'm happy to. So I'm Sepehr, like the fruit pear, makes it easier for people to remember.
Yeah.
I'm a machine learning platform engineer at Coinbase. I've actually only been in the industry about 2 years. I used to sell teddy bears, kind of a different career. And I also teach part-time at UC Berkeley, where I teach people these AI tools and how to use them to maximize productivity or launching startups. And I also run an academy for kids to teach them the same thing for free, which is called AI Scouts. It's kind of my passion project.
That's super cool, super cool. And so what age groups are we talking here?
We actually start anywhere from like 11 and up to 70. Some grandpas want to learn as well. And we like put them all together, but we teach them the basics of AI, how to like understand software and how to use some of these tools that we're going to talk about today.
Amazing, amazing. So we talked about, or rather you talked about a bunch of different tools, a bunch of different agents, and you went through a number of different tips and tricks to get people to be more proficient, more effective with those agents and those tools. Tell us a little bit about what is your environment that you find you are, and I know this is very personal in terms of everyone is different, but for you personally, what's your ideal environment that makes you the most productive?
Yeah, I think my ideal environment is Cursor IDE set up with Claude Code on my terminal. And that's where I feel I'm the most productive. I'll kind of use Cursor for most of the things, actually, like 80 to 90% of the things I'm doing on Cursor. But for deep tasks, I will start off my task with asking Claude Code.
Oh, wow, okay, yeah. And how do you find, like, was that the first time you moved out of IDE into terminal?
Yeah.
How did you bridge that, not being able to see everything in a kind of like typical IDE?
Yeah. I think initially why it started is because our company was actually tracking developers using AI and how much they're using it. And actually in a good way. It's not, I know some companies are like, they don't want to use as much AI because it costs a lot, right? Our company was pushing a lot of AI adoption. And then Claude Code uses a lot more tokens than Cursor does.
Yeah.
So it seemed like I wasn't using a lot of AI, even though I was pretty sure I'm using AI more than most people. So I'm like, okay, let me try out Claude Code because of the token usage. But it turns out like it is really useful, right? For those deeper tasks, I've had so many projects where Cursor couldn't get it done, but Claude Code could get it done.
Very interesting.
And yeah.
And why don't we go through a number of tips then? So we'll talk about Cursor first, then we'll jump into Claude Code.
Okay.
So Cursor, you went through, I think, 14 different tips.
Yeah.
They're on screen. We'll flick through them and we'll pull them up as you find one that you like.
Yeah.
Tell us about a few of the tips that you find. Hey, do you know what? this is really a game changer. Maybe for Cursor specifically, or just generally?
Yeah. I would assume most of your audience hopefully is pretty AI forward, but if not, for the people who don't like AI, Tab AI is where I would start.
Okay.
Cursor has this tab function. For the people who don't like it, just like turn on Cursor and see what it suggests, because a lot of times it'll like write 10 to 20 lines of code for you from you just hitting tab and not having to lift a finger.
Yeah.
So that's where I would start for people who are very against AI.
And this is very AI assisted kind of like tab completion levels of AI use.
Correct. Yeah. Cursor has their own model built for this AI tab complete, which is why I recommend it over a lot of the other IDEs.
Cool. Okay. So Tab, what's next?
Tab, what's next? Let's see. True is like, so I think most people know about Cursor Agent. That's where you use it, right? But the multi-agent mode, I think, is really underrated. And what I like it for specifically is there's like a new model coming out every other day at this point, right?
Yeah.
And like, how do you keep up with which one's the best and which one's not? You kind of want to experiment at the same time. Experimenting takes up a lot of time. So what I like to do is every time some new AI model comes out, use this multi-agent mode where you can set it up so you type in one prompt and have 2 or more AIs answer that same prompt. So recently, with ChatGPT 5.2 coming out, I want to see if I wanted to switch my daily driver from Opus 4.5 to this new one. So I would have it almost shadow whatever Opus 4.5 is doing, see how I like the results, and then after a few tries, kind of decide like, do I want to continue using this or not? So multi-agent is a great one for people to use.
That's awesome. That's awesome. And so with this one, how would it, once you parallelize, how do you then choose which one?
So there's like a 3 benchmark for these models where you can see which one tends to be the best. I don't think that's the best metric. Like you can tell, like Google Gemini, for example, recently ranks really high on that, but people most of the time are saying Claude is better.
Yeah.
So it comes up to your personal experience most of the time. I kind of just take a look at it, see if it did a good job of completing it. How do I like the code it generated? How do I like the response that it gave?
Yeah.
So for example, I really like Claude because the responses it gives a lot of times are more educational than the other AIs, and you can really understand what it did better.
Yeah.
So yeah, I just leave it up to personal experience. You look at it, whatever works best for you, that's the one you end up using.
Yep.
Another great feature from Cursor specifically is they built their own model called Composer. The other IDEs don't have this model, so it's native to Cursor. And it's specifically good at generating code quickly. The biggest problem we have a lot of times with these AI coding is like you type something in and then you're waiting 2 to 3 minutes. And sometimes the task isn't even that complex. For that, I'm using Composer. So for example, this page was generated with Composer in 24 seconds, where something like relatively similar for Claude was 2 minutes and 30 seconds.
Yeah.
And the results are pretty similar.
And that's significant actually, because like I remember when we like were originally like in the very early days of using AI in a more assisted way, particularly in when using the tab completion, for example, we required a really, really fast turnaround, right? Like when you hit tab, you want an answer like within a split second.
Yeah.
Now, with more agent-based, because it goes deeper, you will be more inclined to say, actually, I'm happy to wait for it, 30 seconds, a minute, or something like that, for a better answer. But now, actually, when you look at this, the difference between 30 seconds and 2 minutes, 2.5 minutes, is significant. And actually interrupt your flow, interrupt your thought process when it gets that significant in kind of like difference. So that actually matters quite a bit.
Yeah, 100%. It's so big of a problem that it's like a funny example. But YC actually invested in this company, which is a brain rot IDE. It's an IDE that pops up TikTok videos and games for people to do while they're waiting. So if YC's putting money into it, like there's a problem there.
It's like that classic meme, like my code's compiling, right?
Yeah.
It's like, why are you playing games? Oh, my agent's doing something.
Exactly.
Okay. So yeah, multi-models. What else from the Cursor point of view? Sorry.
Yeah. Next big tip is just setting up your Cursor rules. A lot of people are just using the agent, but not putting down like the groundwork you need to do to really excel with these tools. One of those is going to be rules. The other one is going to be MCPs. So for rules, there are actually 4 different types of rules. You can choose rules that always apply on every prompt, or you can have it be specific where Cursor's figuring out if it should apply it based on the context, based on specific files, or you can just have it set up so Cursor will never by its own look at the rule, but only apply it when you manually tell it, hey, I want you to set up this rule.
Opt-in kind of like information, opt-in documentation. Actually a little bit similar to how Tesla does that with the Tesla MCPs and things like that.
Exactly.
Awesome. Cursor rules really, really important. Why is context so important?
Yeah, I think you kind of got to treat your AI like a basic junior engineer. If you don't give him the full requirements of the task, he's not going to be able to figure it out, right?
Yeah.
So we need to make sure all the details that the AI needs to know, we're providing it.
Yeah.
And I think one really good way to do that as well is with MCPs and setting up some sort of documentation MCP, because there's oftentimes a lot of gaps in our code where the AI will read through your code but still not understand what's going on.
Yeah.
But when we give it access to our documentation, it can read that and fill in those gaps, which really, really boosts the productivity of what you can produce.
Yeah, amazing. And actually, in the session, I asked one of the questions, which was about how to know when to give enough context without giving so much context that it actually degrades the performance. And I guess that's what a lot of the things, like when we talk about cursor rules and the always apply and the apply manually, it's for exactly that reason. And I suspect when we look at if you had a huge amount of context that you wanted to provide, you were probably more likely to say, actually, there's too much context here. Let's add this either manually or add it more intelligently, apply it intelligently. So that way you're not actually bloating context for no reason.
Yeah.
Super interesting and actually a really, really crucial part. Okay, one more cursor rule and we'll jump into Claude.
Yeah, let's do it. You can have a bunch of different rules. I think one that's particularly interesting, Claude shared this themselves, is relating to this context we just talked about. Oftentimes, if you get close to the end of your context window, so you've used up like 90%, then you ask the AI for something, it will give you a short answer because it's just trying to get something out before it runs out of context. But if you type in a prompt like this or something similar, you can tell it, hey, your context is going to end, but like, don't worry about that. You can compact it, actually give me the best answer. And that's one useful tip.
Yeah, one of the things I love, and actually maybe this segues us into Claude, one of the things I love, particularly about the slash command, the compact, is the fact that you can add some text after that, which is super cool. Because if you do a slash, sometimes it'll auto compact, or you just put slash compact, which will make it compact. I love the slash compact where you put text after it, and that text is, hey, this is what I'm going to do next. And what that'll do is it'll based on that, it'll release a certain amount of context that it doesn't need because it thinks, oh, actually, I don't need that for my next task. Super, super cool way of actually saying, actually, I want you to release just the right context and leave me with what I need to do my next task. So that's a Claude tip.
That's a good tip.
That's a good tip. I like that tip. And that lends us into Claude Code. Now, Claude Code, I would probably say, is probably one of the most functional agents in terms of the extra value add that it provides you with. Let's jump into the Claude Code section. What would you say is your kind of like number one tip for Claude Code?
Yeah, I guess Claude Code very similar to the way I use it that I do on Cursor, except I think the use cases are different. Cursor is good because it gives you the visual IDE. You can see what you're doing. It's faster than Claude Code is, uses less tokens, and you can switch between different AI models. But if you're trying to go deep on a task that's difficult, Claude Code does a lot more thinking, takes up a lot more tokens, but usually gives you a better engineered answer. And like at work, I had a project like this that I put into Cursor and into Claude, and Claude Code saved me a ton of time. It like searched the web, found open source repos, analyzed them, gave me a proper solution, where Cursor just like picked something, implemented it, and it was done, right? But Claude Code really saved me like multiple hours.
And I think based on your language that you use in the prompt, it will do the correct amount of thinking based on that. So if you type think deeply, it actually adds the amount. And another top tip, if you type in ultra think, I don't know if you've typed that. Let's go to the terminal quick. If you type in, if I was to go, let's run Claude. If you type in ultra think, it does this crazy thing. This is one of the lowest, the deepest levels of deep thinking it will do. And so if you type something after that, it'll then go in and do really deep thought on that thing.
That's a good one.
So super cool little tip there as well. So thinking, I totally agree. And I think that's why sometimes Claude takes that deeper, like longer time because it does do that deeper thinking. So thinking, completely agree with that. Next tip, what's up?
100%. Other one is sub-agents. This is where Claude Code kind of beats out Cursor as well, where you can set up different agents and give them all their specific MCP tools that they can use. And these sub-agents also have their own context windows. So for more complicated tasks, this might be a lot better. For example, like you might set up a sub-agent that's a PagerDuty investigation sub-agent, right? Every time a page comes in and you call Claude Code, it'll use this one. It'll specifically look at Slack, find the alert, and then go into Datadog, research it, and come back with a solution for you. But for specific workflows that need specific sets of tools, these sub-agents can be super helpful.
And all that extra work it did, adding stuff into the context unnecessarily, just to get a small amount of information, it passes that small amount of information back to the main agent, and then all that other context just gets lost. Right?
Exactly.
It's so useful. We use that at Tesla a lot to do our research on our kind of like our context, and then once we learn this is the piece of context we need to pass back to main agent, it keeps it nice.
100%. Context management is like kind of everything.
Absolutely. Now sub-agents, that's not a thing which is duplicated across many different agents, right? It's quite particular to Claude in terms of I would say the mainstream agents. Do you feel like agents are going to learn from each other and start building these additional things? Do you feel like we'll hit a kind of like feature parity across these agents, or how do you see that?
I think it really depends to how companies handle this context management problem. But right now, even with Claude Code, there's a main agent and sub-agents, and none of the sub-agents actually talk to each other. The sub-agents all talk to the main agent.
Yeah.
So even Claude Code itself isn't like that advanced of what we could be doing in the future, and I'm sure these companies will start to dabble in that.
Really interesting. There's also another tool, I think it's called Claude Flow, whereby they do kick off a whole ton of agents. I think it's mostly command line. And they have this thing called Hive Mind, which is super cool, where the agents have almost like this shared memory where they can start writing to that memory and learning from each other. So yeah, audience, if you're interested in that, I think it's Claude Flow, which is super cool.
Nice.
Sub-agents, super cool. Really love that about Claude.
Another tip while you're introducing other tools, Claudish is another one.
Yeah.
If you really love like the terminal of Claude Code, but you want to use different AIs with it. There's different open source libraries that do this, but Claudish is one of them. Looks exactly like Claude Code, but you can call like Gemini, ChatGPT, whatever AI model you want from it.
And that's and people would do that because they love the Claude Code UI or DX UX, but they presumably have a different model that either the company have agreed on or something like that. Do you think you'll get like much of a benefit in terms of the underlying LLM being maybe certainly better in certain cases or not? Or would you say, if you don't care, Claude Code is probably better to use Claude with?
I think if you don't care, Claude Code is probably the best to use at this point. Maybe that changes. I wouldn't really like them in Claudish. It's just exactly for that specific use case.
If your hands are tied, it's a good.
Another thing, like when you're using these AI tools, it's important to evaluate, like, are these actually working or is this slowing my team down? A lot of times, actually, initially teams will adopt AI and see a little bit of slowdown before they ramp up. And that's kind of the learning curve that it takes to start using these tools. But overall, you want to be tracking these metrics. There is no perfect metric, is what I found, right? But what you want to do is just track a bunch of different things, like PRs merged, how long from a PR created to merged, etc. And then, like, what I find most times is you in the company build a qualitative story that you want to tell your management. But when you have these metrics, you can pick and choose which ones you need to use at the right time to tell that story and back it up with evidence. So that's where I think it's like really important to gather as many different metrics as you can and use them when you think it's right.
I couldn't agree more. I think in the past, AI adoption has more been like people are just wanting to adopt AI tooling, and they have that almost that push from up top, like you have to be using AI. Let's all do it. And I think there are certain people who are now looking at this thinking from a productivity point of view, how much value is this providing me? I was talking with Tracy Bannon yesterday, actually, and Tracy, he was giving the closing keynote, actually, at QCon, and hopefully we'll chat to her as well. But Tracy was talking about value versus things like velocity, because velocity is just a metric, right? It's a metric, and it can be gamed. There's a whole different ways. But value is super important. It's like, what is this agent actually giving to us from a business value point of view? I think it's super crucial. Completely agree with you. I think the impact is
100%. Kind of alluding to what you're talking to, they have some complicated research methodology that they did on over 100,000 employees. But what they found out is AI is helping generate 30 to 4% more code than before. However, 15 to 25% of that code ends up being junk that gets reworked, right? So they estimated the actual productivity gain is like 15 to 20%. I would think it's higher if you're using AI in the right way, but good to know. Like, there's a difference between value and just straight output.
Absolutely, yeah, and that's the biggest trip hazard to just output versus outcome and measuring that wrong thing. 15 to 20% though, still impressive, and we expect that to probably grow as well over time when LLMs and etc.
100%.
Amazing session today. Thank you so much.
Thanks for having me.
Absolute pleasure to be in it and meeting you at QCon today.
Thank you for having me.
Absolutely. Enjoy the rest of the conference, and yeah, speak to you soon. Hello, and this time I'm with Ian Thomas, who's a software engineer at Meta. So Ian, welcome to our podcast.
Thank you for having me.
And as soon as I saw your title on the schedule, I thought I have to have Ian on my on the podcast, because your title today was AI native engineering, and of course this is the AI native dev podcast, and I'm like, look,
it's a perfect
match made in heaven. So tell us a little bit about the session.
So this is a kind of a case study of what we've been doing in my team and my wider org in the Reality Labs part of Facebook and Meta, where we've had a sort of ground-up adoption program for people who are looking to experiment and develop with AI as part of their workflows, building on all the various tools that we've been getting access to over the last few months, and generally seeing how we can accelerate ourselves in terms of productivity and making more I guess, product wins and outcomes for our teams.
And I guess in terms of like every organization is different, but generally, how would you say adoption is of these types of tools in a large organization like Meta? Do you have like people who are diving in, people who are stepping back, and then the majority maybe leaning into it slightly, or where does that sit?
So I'd say, well, it's changed a lot over the last 6 months.
Yeah.
So I can only really speak to my org and the patterns that I've seen there. We had a few people that were really keen and sort of experimenting, and they were finding value of these tools outside of work. And they were really keen to see how they could apply it to internal. Meta has some interesting engineering things because it's very in-house. It builds its own tools and platforms and things. So there's some quite bespoke ways of working there that maybe you can't just go and pull some of these things off the shelf and apply them to our code base.
Yeah.
But yeah, so we had these few people that were really passionate about it, and then we had a bunch of really senior engineers who were perhaps a little bit more skeptical. And then gradually over time, we've seen adoption grow, and there's been more of a push from the company overall and saying, look, this is going to be something that we have to take seriously.
Yeah.
You've got access to all these tools, let's go for it. So the adoption now is pretty good. I think last time I checked, we were over 80% weekly active users.
Oh, wow.
And the way that we measured that sort of changed subtly. So now it's considering 4 days out of 7 usage of any AI assisted tool.
And can you say what tools you're using, or?
Well, we've got a whole spectrum of internal things. So we've got MetaMate and DevMate, which are the kind of 2 main ones. One's more of a chat interface, and the other one's more for like coding and agentic workflows. There's a whole bunch of stuff like Gemini, Codex, Claude Code, etc. We've got access to third-party tools as well.
So devs are kind of like trying to find what works for them, and teams are trying to work out what
Exactly, yeah. And a lot of the tools like MetaMate and DevMate have access to the models used by things like Claude Code as well. Right. So you get to compare like things that have got a bit more internal knowledge than external. So it's quite good.
Yeah.
The versions that we use generally are kind of tailored for Meta use cases. So they're kind of a bit more restricted than the generally available stuff, but they're still pretty powerful.
Awesome. One part of your session that really resonated with me was when you started talking about community and growing that community. Why is building that community so important when we talk about sharing that knowledge and kind of that growth in adoption?
So I think one of the things about metaculture is that it's very engineering empowered. And so what that means is if you can get engineers to support something from the ground up, you can go a long way. And there's a popular phrase, code wins argument. And I think in this case, it's a case of like proof wins argument. So if you've got people that are going to be forming around this idea and these concepts, they can bring them up to a level where people are saying, hey, I'm getting value from this, and this is how I'm using it, and this is what's working. It attracts other people who are going, okay, well, if they're doing it, then maybe this will work in my case too. And I think that community aspect helps to get a bit of authenticity and people feeling like they're part of a community, and it helps to kind of push everything along with a bit more momentum. Whereas sometimes if you get like a top-down mandate, engineers can be quite skeptical people at times, it's a bit cynical, and someone's like, oh, well, if I have to do it. So, but rather it's bottoms up, it's a bit more kind of, okay, we can make this work, and I think it's going to be a great thing.
So what was being shared then? Like problems, as when people were having problems or people had questions, wins maybe, were people saying, hey, this works really well for me, maybe context or rules, things like that?
Yeah.
How did the community work?
All of the above, right?
Okay.
So we have, one of the things that we rely on a lot is Workplace, which is sort of like the professional layer on top of Facebook. It was an external product until fairly recently, so we use this heavily. And that's kind of the basis of where this community is, and we share things in there. You can post, people can comment. It's like a social experience, but for work. And so what we were seeing was people were coming in, they were asking questions, they were saying, well, I'm trying this thing, or have you seen this tool's available? Generally kind of keeping everyone informed about what's going on. And over time, it's just gradually grown and grown. We never really forced anyone to join. It's not got like auto enrollment or anything. And I think last week we hit 400 members, which is pretty good for something that's kind of a grassroots initiative.
Yeah, self-sustaining, like one of some of the best communities like that. And I guess one of the things that are really nice about communities is that everyone, you get so many different people at different levels of their experience and adoption. And this kind of like leans into one thing that you mentioned as well, which is like these maturity models. And I guess there's maturity in terms of how an individual is using it as well as a team. Talk us through the maturity models and why they're important.
So the thing about the maturity model, I intended it to be used for a team, but there is a dimension on there which is about individual productivity as well. So you can reflect on your own kind of performance and ways that you're getting value from it. The benefit of it being a team-based thing is that it opens up the conversation within your team.
Yes.
And so you can generate ideas and have action plans that are specific to you, because every team's going to have slightly different context or different levels of ability and different interests. So that's great. We tried to model it in a way that was going to be fairly agnostic of the tooling and be durable, because again, the value I think is that you can have these models and you can repeat the assessments time after time and see how you're progressing. And we do subtly tweak it every now and again, but generally it's kept fairly consistent.
Yeah.
And then, yeah, like I say, the teams run these assessment workshops and they can have the discussion, and that's where the real value lies.
Yeah. Let's talk about value and wins. What were the big wins that you saw, and how did you share that across the community?
So initially the wins were people saying, oh, I'm using DevMate, which is part of our tool set in VS Code that we work with day to day. So I'm finding ways to use this to like understand the code base better or what have you. And there were some early examples of people just sort of going for a big problem and putting a prompt in, and they were getting a bit lucky. And then there was equally some people that were suffering that wasn't working at all.
Yeah.
But then we found there was kind of repeatable patterns emerging around things like test improvements, or how to make code quality improvements, or reducing complexity of code.
Yeah.
And that was when we started to experiment with things like unsupervised agents. And you could say, okay, with this category of problem, say like we've got test coverage gaps, we want to go and find all the files that are related to this part of the code base, related to this on-call, say, find the ones that have got the biggest coverage gaps, and then using this runbook that we put together, go and cover them, go and produce diffs that help us to bridge the gap. And that was the sort of thing that we take lots of hours of manual work. And as this sort of evolved, we found actually we can go and use the tools to go and query the data, do the analysis, and then generate the tasks for itself to go and then fix the tests and add the coverage. And I think the end result was something like 93.5% coverage was achieved, which when we were way less than 60% to start off with. So, many diffs landed.
And it sounds like huge productivity gains.
Yeah, so that one I think we ended up doing it in about 3 hours to achieve this, so which is incredible. And this is, again, it's one engineer was just saying, I've got a hunch, I think this is going to work, I'm going to go and play with it. They found a pattern that worked, and then it became repeatable. They shared it to the group. And I think I said in the talk, one of the things that came about from that was another engineer was like, hey, this kind of works. I've got all these tests that are running fine, but they're a bit slower than I need them to be eligible to run on diffs. I wonder if I can do the same sort of thing. Can I go and put this tool to use and go and find all the tests and see if I can reduce the runtime down? And I think they achieved something ridiculous, like 1,900 tests were improved.
Wow.
And so it's a huge amount of work that you just wouldn't have done.
It's hard to estimate how much time that is, and you're probably right. It just wouldn't get done. So it's a beneficial increase in quality versus just time save.
Exactly, yeah. And then in terms of the value of that one, I think I was chatting with that individual engineer as well, and I said, look, what would be amazing to know is not just how many tests you fixed or improved. Can you tell me how many issues that's actually caught? Because they're now eligible to run on these diffs. And he went away and he found the data. It's like, yeah, look, in the time since I launched this, at least 200 changes have been stopped because these tests now run, and previously they didn't. So that's it's harder to get those kind of value metrics for everything, but that's the sort of thing that I think it makes the difference, and it helps to persuade people that this is going to be a different kettle of fish,
and we're just starting.
Amazing.
Well, thank you so much for the session and joining our discussion here. I very much encourage folks go to the QCon website, check out the talk in full. But for now, Ian, thank you very much. Appreciate it.
No problem. Thanks for having me.
Hi there. Now I am with David Stein, who is a principal AI engineer at ServiceTitan, and David gave a really great session yesterday, in fact, which was called "Moving Mountains: Migrating Legacy Code in Weeks Instead of Years." Very nice title. Really engages the thought processes of what is possible with migrations in and around AI. David, first of all, tell us a little bit about what you do. Tell us a bit about ServiceTitan.
Right, so ServiceTitan, we are the operating system of the trades. And so what that means is, this is for trades and residential and commercial building services industries like plumbing, electrician, HVAC, roofing, garage door, and so on. A bunch of these contractor businesses for regular service work and for construction. ServiceTitan builds a technology platform that helps these businesses run their business. So end-to-end platform supports everything from customer relationship management, taking payments, to answering the phones, and we have a whole suite of capabilities in our platform around everything you need to run a business like that. So that's what ServiceTitan is. When I work as an AI engineer, a principal AI engineer at ServiceTitan, and you might wonder, like at first, what are the AI use cases in the trades businesses? And there's actually like a lot of really interesting AI applications that are really important for companies that want to run a sophisticated operation today. And just to name a few of them, if that's
Sure.
can keep going there. So there's one thing that we are doing is around what's called job value prediction. We can, a lot of trades businesses, when they have, many dozens of technicians and lots of customers and many jobs that they're going to serve in a particular day, they have a big task to do at their main office around matching which technicians are going to serve which customers on a particular day. And we have a bunch of intelligence in our product that allows for this scheduling and dispatch to be matched efficiently to basically help our customers run their business better, more efficiently. And that's one example, but there's a bunch of other areas too, using, like, for example, we have a voice agent product that, voice AI answering service, so that our customers can kind of answers the phones for our customers, so that it can help their customers schedule service appointments 24/7. Those are a few things that I work on. Yeah.
Yeah, and so tell us, and so one of the big things about your session was about how you took some legacy application and you wanted to migrate it. So first of all, why don't we talk a little bit about the legacy application? What were the pieces of that application that you needed to migrate? There was a bit of data, I think. There was some code. Anything else?
Yeah, so in the talk, it actually focused on a different area than the things that I just mentioned. And it related to a migration that we've been working on as part of, like, this is, like all large tech companies have this issue. If you've been around for more than a few years, you've, your software that's been in existence for more than a few years using, legacy, using components that have been around for some time, not that no longer resemble the way that you would rebuild those things today, using more state-of-the-art foundations. And so anyone who's been in software engineering, for long enough has had to work on a migration at some point, where you have to kind of unpack code that was written a long time ago. Maybe the people who wrote it aren't on the team anymore. Where not all of the context is easy to find, but you have to do the work of picking those things up and moving them into a new implementation on an improved platform. And those kinds of projects, that all companies have these projects, ServiceTitan included, they're notorious for being, they take a long time. There's a lot of kind of toil in understanding the old legacy code and moving it over. So the example that I talked about in the talk was around our reporting application. ServiceTitan has a reporting product that basically allows our customers to see all sorts of business metrics and KPIs relating to their operations and their financials and their business. And we have a bunch of very complex infrastructure that supports that. And something that we do periodically is move the underlying machinery to use better and more state-of-the-art infrastructure. And so that's what this is about. So the specifics are, we've been working on, working with dbt metric flow. It's like a metric store technology based on and layered on top of Snowflake, because there's some of the details of the stack underneath. But there's this big task of how do you take this code that was written a long time ago, touching, legacy. I don't know how many of these dirty details I should go into here, but I'll let you actually ask the question. What do you want to know?
The interesting bit.
Yeah.
So why don't we talk about the AI piece first of all?
Sure.
So we know there's a report, so it's a reporting part of the application. There was some code that I think you said you changed language on for that. There's an amount of data as well, of course. Did the data migrate, or was that pretty much staying where it was?
So Yeah, so we're talking about shifting from an architecture that is based on the legacy stack,
Yeah.
which is written in C# with a ORM programming model that is operating against SQL DBs in production, and shifting that to a kind of data lake-like architecture with a semantic layer and a kind of a query engine on top that allows us to serve the same kinds of metrics queries, but on a off-production architecture. And there's lots of reasons for that. But is that what you're?
Yeah.
Okay.
No, that's fine. And so in terms of, so you used agents to help you with this.
Right.
What would happen if you just said to an agent, here's my environment, I need you to migrate this, create a plan, and do it yourself.
Right.
What would be the problems?
So for a product like this, when you have hundreds of metrics and each of them are underpinned with a bunch of code written in C#, with all the issues that I mentioned before about not all the context necessarily being exactly where you need it, there's a lot of complexity in that. You can't just open up even the state-of-the-art coding tools like Cursor and say, hey, please migrate all of our metrics into this new abstraction on this new framework. And by the way, convert from C# into writing SQL with a YAML for metric flow on top. It doesn't work to do that, is what we found. In order to get traction there, you have to really break down break down the mountain of that problem into small pieces. It sounds kind of obvious if you say it in this way. You break it down into standardized, you break it down into basically a bunch of similar tasks that can be verified in a standardized way.
Yes.
And then you assign you basically construct a long task list with phases for individual sections of the task. Like move these first 5 metrics as the first phase, and then the next, and so on.
And who's doing this? Is this humans doing this? Is this humans with agents as an assistant doing
Right.
this?
So humans are choosing the task list, right? Are enumerating, okay, these are all of the metrics that we're going to enumerate, that we're going to migrate in phase 1, and these are the metrics that we're going to migrate in phase 2. So humans are making those choices, as well as what the target architecture is that we're going to be putting these things into. And humans are also, with some help from AI tools, are constructing all of the context that's going to go to the coding agents to actually enable them to do the migration work for those pieces.
And you went into a bunch more detail in the talk. I very much recommend, it's a recorded talk, I believe, so it's very, very, very much recommend folks go to the QCon site and check that out. But in terms of the agents, now we have those tasks. The agents now need to take those bite-sized tasks, they need to perform that migration, and then essentially you can run the validation to say, did this work, did this not work, what needs to be changed after that. In terms of, I'm really interested in what needed to be done to the agent to best prepare it for that actual migration.
Yeah. It's kind of hard to say it all without the visuals that we had in the talk. So people can watch the talk if they want to see more of these details. But we talked about standardizing the tools that need to be used to do each of these tasks. And so that means standardized tools for context acquisition. So the agent, just like an engineer, is going to need certain context in order to be able to migrate one of these pieces of metrics code.
What type of context here are we talking about?
Context in terms of what the underlying data looks like in the database. So the agent will be looking at the reference code, and it will have references to some tables, and you need to know what some example data actually looks like that lives in those tables, and what the schemas of those tables are. And that's and in terms of what's available in the destination platform, confirming okay, we have this table in Snowflake, we know that the data is there. Understanding even anything that a human engineer would need to see in order to be able to correctly write the code that's going to calculate those metrics in the new platform. We want the agent to be equipped to see that too. So we would have a standardized tool for context acquisition, or a set of tools. And what that would mean is not tools in the sense of actually MCP. We didn't get that complicated with it. We just made sure that the CLI tools, which is CLI tools that an engineer would be able to use to get these things, that those are set up and ready for the agent to use to be able to get access to what it needed in order to be able to do the task. Then the other really important piece is around giving the agent a kind of environment in which to run the code and a kind of simulation engine, or I call it like a physics engine in the talk, which is not really about physics, but it's about a script or a program that the agent can run to try out the code that it has written, to actually run the metrics code in a context that resembles a legacy application so that it can produce an output that can be directly compared to the output that would be produced by the legacy code.
And I think what you said in the session was you're not using production data at this point. It's almost dummy data a little bit to say, if you mess up, I want you to mess up in a safe environment. But it gives a good enough way of you being able to say and validate almost.
Yes.
Yeah, I see what you're doing. You're within an environment where you can almost like test yourself and make sure you're able to migrate, and we can understand if that's successful.
Yes.
And so from a validation point of view then, or a validator point of view, trust is a massive piece of this, right? In terms of when you push big pieces of code and things like that. What levels of validation did you have there? You obviously mentioned, you had this like environment that you created. What else did you need to do before you kind of like said, right, we're going to put this live?
Right. So the validation that enables the tasks to be able to be done automatically by the agent, we have machinery there that can compare the output produced by the new system to the output produced by the old system. And so there's a separate set of validations that we also run before actually doing production cutover, because it's obviously extremely important that the data be right when we're showing it to our customers. In terms of the details of those, I'm not sure what level of specifics to go into there, but hopefully
I think what's important is you were effectively replaying things that you saw in your previous production environment, and you were ensuring that the output that you got from your previous production environment was the same and equivalent of what you were getting with the updated code and the updated flows.
Yeah, that's right. So replay is a good keyword there.
Yeah.
So we of course have like the logs of what queries are given to the old system. We're able to play those queries against this engine that runs using the new platform as well. Yeah.
In terms of the LLM itself and the agent itself, how smart does that actually need to be? Does it like, did you hit any limitations in terms of, we need to change model or anything like that? Or was it pretty basic in terms of what it actually needed to do given the context, the validators, the intelligence?
So I had a couple slides about this. At one level, the agent doesn't need to be that smart. It doesn't really need to be as smart as a human engineer. Part of the point I try to make in the talk is that as long as you have that kind of self-healing loop where you're able to empower the agent to check its work and then try to make corrections if it didn't pass validation and the metric computed by the new system doesn't match the metric produced by the old system. It's kind of interesting. This project really kicked off for us when Claude for Opus was released in, I think it was May of this year. We had done some experiments before that at seeing how well the different coding LLMs could understand some of our legacy metrics code. And it turned out that like they could understand it to an extent, but the first time that we encountered, the ability the LLM to really be able to understand that stuff well enough to do a pretty good job of restructuring the code for the new platform was with Claude 4 Opus, which is one of the bigger models that's out there. So it needed, in our case, to be pretty smart, but it doesn't need to be perfect, which is an important point, because I think that sometimes people kind of get caught up in like, well, bots will hallucinate sometimes, and are they really as good as a human engineer? But like, part of what I'm trying to say is that that's not the point, as long as you can have this self-healing loop.
So it's interesting that you needed that kind of like Opus 4. Did they get stuck at any point? Were there any common kind of like ways in which the agent or the LM failed, maybe through lack of context or lack of intelligence or anything like that?
Yeah, so we have a slide about this as well. So the in the talk we talked about a few pieces that we put up to kind of govern this process where you're going to have the agent go through and do these tasks one after the other. And it's not the case that we came up with this idea and we tried it one time and it was able to just do all of the metrics and migrate all of them in just one take. That is not how it worked.
Yeah.
Instead, the first, 10, 15, 20 of them, we kind of did them many times in order to get to a point where the standard context that we present in the system prompt and like the migration goals.txt that I mentioned in the talk, as well as the way we even break down the tasks and at what granularity, and also the behavior of the validator and simulator tool itself. We had to kind of tune those to get them to work well enough that the agent was able to reliably get through. And so we would encounter situations where the agent, thinks that it successfully migrated or that it successfully converted, rewrote the code for a particular metric so that it would work in the new platform, but that upon, for like, let's say a set of them, it would say, okay, I finished number 1, great. Okay, try number 2, great, did number 2. And then we just let it go until it had done several of them. And then we would find, like, upon inspection this is obviously before shipping any of that code, we would find that, like, well, there are some problems here in what the agent did. And so we would have to go back and like rewrite, add certain things to the context and improve the behavior of the validator and the simulator so that from that point on, the bot would be able to do a better job of producing the code. And another thing I guess you can find is cases where the agent would get stuck because it knows that it's not able to make progress on a particular task, and there could be many reasons why that would happen. And an example that I like to talk about is like if the agent just doesn't have sufficient test data for that particular case, it will struggle to be able to confirm that the code that it tried to rewrite is actually going to work, which is a similar problem that a human engineer could have, but they're trying to write a new version of some code that fits a new paradigm, but where they don't have sufficient test data to be able to confirm that it's going to behave in the same way. So making sure the agent has that context.
Yeah, absolutely. And I guess in your session, the session title was Migrating Legacy Code in Weeks instead of Years. Do you have any thoughts in terms of, well, actually how much time, well, first of all, how long was that process? And I guess secondly, how long do you think it would have been had you not have used AI as a part of that?
So we talked about the number of metrics I mentioned in the talk is 247 metrics that were moved into the new platform. It really does go very, very quickly once you get that flywheel running using the approach that we're talking about. So this is part of like once you get that assembly line working where you have sufficient context in there and the right tools for context acquisition and the right tools for validation, you can get pretty good agents to run your whole migration really fast. So in terms of how long it took, I would say that like the first 20 or 30, like I mentioned before, as well as getting those tools and those fixtures right, probably took 1 to 2 months. Trying to remember my exact estimates there. Once those things were in place, going from that 20 or 30 point all the way to almost the end of that list of metrics was really fast. So it was like just a few weeks. And it would be, the reason that, what's so compelling about this is that, as we talk about in the talk, anytime you would be needing to have an engineer, read the code in one language, look at the underlying data, make sure that the logic can be captured and put into a new abstraction like that, that would be like work you have to assign to an engineer. Those tasks would stretch out over a long period of time. The way we estimate it, like I said in the talk, it would take quarters to do that kind of work where you're going to have engineers migrate all that code into a new platform.
And distract them potentially from a future product work or anything else.
Right. So, I mean, that's time that engineer can be spent working on something else. But there's also a sense of like agility that I want to kind of people to take away from this, where like a lot of companies and also where I've worked in the past, like there are often, there are some big migrations that are deemed high enough priority to actually kick off and do, despite the huge costs that these things used to take. But there's also a bunch of other kinds of tech debt cleanups and like, you might almost say desire to migrate something to use a better foundation, but where engineering teams struggle to prioritize those things because of how long they take.
Yeah.
And so trying to say here that if you can break down that problem in the right way, like we talk about in the talk, you might be able to do those migrations that you've been wanting to do
Yeah.
much faster than you might have been able to do them in the past. So it kind of hopefully helps people think about their strategy a little differently, given what we have now.
Amazing. David, thank you so much. And by the way, ServiceTitan, they're hiring right now at the time of recording.
That's right. At the time of recording, we're hiring. So yeah, folks can find me on LinkedIn. You can reach out if you're interested. There's a lot of great stuff that we're doing here. So
amazing. David, thank you so much. Appreciate the amazing session you gave yesterday. Thank you for giving us some time, and enjoy the rest of QCon.
thank you so much.
Appreciate it. Hi there, joining me this time is Wesley Reisz, and Wes is Technical Principal at ThoughtWorks. Wes, welcome to the podcast.
Thank you. It was great to be here. I'm excited to be on it.
Tell us a little bit about what you do at ThoughtWorks, first of all.
Great. So I'm a technical principal. We call them technical partners as well. And so what I basically do is I lead an account, all the technical aspects of an account. So on this particular account that I'm leading, it's a large state organization in the United States. I've got about 10 developers, about 18 people total on the project with design, project, product, those type of folks. So we're basically building a knowledge graph for a state agency that's using a deep research agent to be able to populate this knowledge graph. Then we're building applications to access that knowledge graph to be able to answer questions for the state agency. So I've been doing it about 3 months for this particular project, and yeah, that's what I'm doing.
Awesome, and I joined your session yesterday,
Yeah,
really interesting session. The title, for those obviously not at QCon, AI First Software Delivery, Balancing Innovation with Proven Practices. And you talked a ton about the various different levels of using specifications as part of your software development.
Yeah.
Super interesting, but going from, I guess, using specifications to assist your development all the way through to specs being that spec-centric piece.
Right.
An amazing blog from Bigita, who we had on the podcast before as well.
Absolutely.
And you introduced a really interesting framework called Ripper, or Riper.
Ripper, it goes back and forth.
Ripper 5.
Yeah.
Why don't you introduce that to the audience, and then we can kind of like delve deeper into it.
It's first, to be fair, I didn't come up with it. It was, we discovered it on a blog post or a Cursor forum that was in, I think, March of this year or so, when we first ran across it. But what it stands for, it stands for research, innovate, plan, execute, and then review. So it's that plan, execute model, but it goes a little bit deeper. And the reason why I think it's so important is you've been interacting with an LLM, you've been in a chat console, and you're trying to do something, and it has to have the context of what you're doing. You don't always are in the same mindset. You may be trying to research a particular thing, but it jumps into coding. Or you may be planning and it jumps into coding. Or you're coding and it's not really doing any planning. So what the Ripper 5 model does is it provides a set of instructions that you can pass as a command. We're using Cursor. So we pass it as kind of property for our IDE to be able to have this context. So we give it a command. We say we're in research mode. And what that does is it tells the LLM that ask me questions, analyze the code base of where you're at, for example. But don't do, as important as what it can do is what it can't do. Don't do coding, don't do planning. Right now, I just want you to understand what the code is, what my spec is actually trying to do, so that way I can provide more details to refine the spec. So this Ripper 5, it's kind of like an execution model of how you work with the LLM, and we do that in pairing with the developer.
It's really interesting because like when you sometimes give an LLM a task, it will think it knows enough and jump to the next thing. It's almost like if I have enough information that I can give a response, I'll try and do that, rather than actually thinking, well, I have enough information to give a response, but I don't have enough information to actually give the response that you as a user want to provide back. So in terms of the context that you give the LLM at that stage, I presume it's like similar to rules, or it's essentially like a step-by-step process to say, look, this is what you need to do, and then this is what you shouldn't do. Or if you find yourself doing this, stop and, at least complete that before you say, I'm done, and then pass over to the next. Is that how it works?
Yeah, so I kind of jumped straight into the Ripper 5. So what we start with is spec-driven development, as you well know. So what we define is a well-defined spec. So it has things like acceptance criteria. We're moving to actually put behavior-driven development type tests in there, so that way We're getting the test up front before the code is written. A lot of times when you have it generate tests, as you well know, it will fit the test to the code and not create the test, then the code validates it. So by getting kind of BDD style tests up front and in the specification, it kind of creates a test-driven development type approach that the spec follows. So the first step is getting a well-defined spec. One of the questions that I often ask when I talk to people about spec-driven development, though, is at what level are we talking about? Are we talking epics? Are we talking stories? Where are we when we talk about specs? What we're focused on right now, remember, go back, this is a team that we just stood up with a new account, brought these people together, working with kind of a traditional company, a state organization. So we hadn't been here long. We didn't have a lot of domain knowledge yet about all the processes that we were doing or how we were working. So what we took was defining a process using Ripper 5, how we're going to work with the LLM, starting with the spec, and then we pair developers with that process. So with that well-defined spec, with that definition of done, with the acceptance criteria, with the information that's there, given that spec, we then go into that first R stage. And again, this is just a command that we share with all of our development teams, submodule we pull into our repo. That means do research. So do research, give it the spec, give it the code base that you're working on. Make sure you understand what it is that this is going to do. Ask me questions, and then we refine that spec. So as it asks questions, we put it back into the spec, so that way we keep refining it, then we go to the next stage.
Yeah, it's a really interesting point, actually, because when you say ask me questions, I like that, because when we talk about research, I guess there are different ways in which the LLM can get answers. It can kind of like determine it itself based on its training. There are a ton of tools that are available to LLMs these days and agents. Maybe it does a web search or something like that. How autonomous is this research? Is it very interactive with the user and kind of like almost like prescribed by the user, or can it just go off and come back?
Well, so that's the beauty of it, right? You do have the tools, so you can use a tool for web search. If, in my particular case, we don't have like an MCP client that has broader context, but if you did have context, like some of the products out there that might provide some context back to it, you could certainly use those. In the case that we're doing, it's primarily Ask Me. You can do a web search, but generally it's Ask Me and then the developer's providing it back. But there's nothing that precludes that adding the additional tools into it so that it can ask, that you can use it. But it's up, in the way that we're doing it right now, we're using the developer up front in the process. As we move along, as we gain more domain knowledge, as we gain more of the context of how this business operates, we can start to put evals in place where we can do things more autonomously. Right now, we're taking a very supervised approach, being that a developer, a pair actually, is engaged with this research.
And it keeps that developer in the loop as well. So who determines when research is done? Is that a developer decision?
Yeah, it's a developer decision. So we're firmly keeping that developer in the process.
Yeah.
So once that research is done, then the next stage of Ripper is innovate. And that's that part where you can do things many different ways in software, right? Like implement this. What are the ways that you would implement this? And it might give you 1, 2, 3, 4 different options, and you're like, you know what, I like 2. Or actually, I like 2, but let's make it more evented and make it event pass. You pass that to it. That then goes back into the spec that refines it, and that's the innovate stage.
And so the innovate stage is still updating the spec, but it's updating the spec more in terms of the how the developer would want that to be implemented.
So it's refining the spec, it's adding more detail to it. So a lot of the tools do some of this stuff as you go through, but this, we're taking a very simplified, this is just straight markdown. We're interacting with the LLM and the developer and enriching the markdown file.
And is it typically, I mean, of course it's just markdown, so both an LLM or a user can kind of go in and play with that. Do you find people leaning into the LLM only to make changes, or do you find people more handcrafting as they go as well?
So this is a common question that goes back and forth. What I push for is to make sure you go back to the spec at this stage. You're firmly in the spec. Now, I do take a spec first approach. I believe once the code is developed, that the code is the source of truth. At this stage, though, we're refining the actual spec.
So we've done the innovation, and that refines the spec. P.
Now, P is planning. So in planning, what we do, if you think back before AI, if I had a story, a well-defined story, and we're doing on a Scrum team together, and say we're on this team, we got 3 or 4 other developers, we don't know who's going to pick up this story. So we've got this story, we go into planning, and we look at this thing. It's like, how are we going to develop this? And you're like, oh, there'll be a React component that we need to build. There's maybe a service that needs these methods. We need these kind of things passed into it. Maybe this model's there. We might need to create this repository. We need to do something to be able to migrate for the database, to do updates. But we like task it out. We literally break down what's going to be done. We write the task. So if you and I aren't here and somebody else picks it up, another pair, they have the same task. They have the same mental model of what's being required to do it. We use the same thing with planning. So what we do in planning is once we have this, this stage, there's a command that we'll run that's do plan. And what do plan, we give it the spec. What do plan will do is it will first break it down into individual tasks. So do that same tasking stage. Then as a pair, we review those tasks and we look at it and go, okay, say do these things match what we want, or do we want to rearrange them or do things differently? One common example I think I used in the talk yesterday was in the example that I did when I set up when it tasked it out, I was doing a Python project. And it didn't set up a virtual environment first, right? And everything I do, I want it set up in a virtual environment, so I'm sandboxed off and nothing's manipulating my machine. So the first thing I did was go back to it and say, hey, add a virtual environment to this plan. Going back to the spec, I'll keep trying to update that. Sometimes I have to go to the plan if I can't do the spec, but what I do is I task these things out. So now I have this task, set up the project, do this component that I mentioned, or do this service that was there, this repository, the migrations. I lay all those things out. Once we've done that, then what we can do is go to the next step where we actually create the plan for that tasks. In the part where we actually do the task for that, we try to keep these things as atomic as possible, so that way they're like a discrete commit if at all possible, so they're not leaking across different tasks. There's a couple reasons for that. One is they do have that atomicity, but also we might split tasks up. You might do one, I might do another. We might parallelize some of the work. Some things might be dependent. We'll build that into a little task plan that we do through it. But we'll do that so that way we can implement each of these things individually. So that's the planning stage.
Awesome. And with planning, it seems like particularly with things like Python, for example, there are a number of common best practices. Like, I want it to be contained in my own environment. How much of this is almost reusable across different projects? Because there's probably an amount, whether it's styling, whether it's just ways of working, whether it's maybe test-driven development, or whether it's a stack that the teams are most familiar with or want to deploy with. Is there like an amount that you kind of say, you know what, for this customer, I want to reuse this for every single project, therefore I'll make this some kind of context that every project can reuse?
For us in particular, we're using Cursor, so I'm going to answer it through a Cursor lens, but how I answer this really is irrelevant on the specific tool that you use. So what we really start with, even before you jump into the Ripper 5, is what are some of the foundational rules that we're going to establish. So the first rules we start with around documentation. Anything that's created, use Mermaid to be able to diagram things. We'll create some things like that. There's some general rules that we have on programming abstractions that we want to have. I know some people will actually put rules in there about DDD, for example, if you want to leverage domain-driven design, or maybe a clean architecture that you'll add into the rule set. So you start there. As you go through that Ripper 5 and you go into planning and you discover those things that are cross-cutting that you want, we create rules. Current project that I'm working on, I'm using Spanner. So there's some rules on how Spanner operates. So what I'll do is but I'm still somewhat new to Spanner. So as I'm going through that and I'm working with Spanner and I'm doing DML or DDL, doing updates, and Spanner has a certain way of dealing with it, I'm like, oh, I ran into an issue here. So I add that into my rule file. I share that out with the submodule. Other developers pull it in. So when they're running another specification that touches on Spanner, they're picking up that DML rule that I added into it. So we use rules for those particular things.
Gotcha. And how much of that is like checked into the repositories?
All of it is. So what we do is just create a submodule. So we have a Cursor submodule. It's our rules. We put rules and commands into that. And then for all of our repos, we've probably got 5 repos in this one. It's not a mono repo. And so what we do is we just have them clone the submodule, and that pulls down the latest rules, and then we apply those rules as we go throughout them.
Gotcha. E is execution.
Execution.
Right? Execution.
Yeah. So I should say, we talked about before that as important as what you can do is what you cannot do in each of the stages. So when you were in research, innovate, and plan, one of the rules that you cannot do is execute. You cannot create code. And that's important to make sure that the LLM and the developer are in sync before they get to that stage of execution and creating the code. So now we're in execution. And now you don't plan anymore. You follow the plan. That's the rules that has to actually happen.
What if you realize during execution, actually, we need to actually go back to planning, or we need to go back? Is it a process that you can bounce around, or is it kind of like best done where you agree completion before you go, and it actually makes it a bit messy to bounce around?
It's a fine line. So the answer is it depends. The general rule is to go back to the specification and replan. That's the general rule. But sometimes LLMs can take a minute, right? You can think a bit. So maybe you just want to make a small change to the plan. That's frowned upon, but that's okay. If you do it, you do it. Once you get to the execution stage, it really begins to depend. I am a firm believer, like there's different models that you can take. When we talk about spec first development, or spec-driven development, are we talking spec as a source of truth, where every change must go to the spec? A lot of folks, a lot of tools out there that drive specifications maybe take that approach. I haven't found that to be really successful with me, because it forces you to move up too high in the abstraction. Because if you're too low, then you have specifications that start to collide. So I haven't found that perfect balance for me. So I tend to use spec first, where spec is used to define what we want to do in plain English. We review that, we generate that when we review what's there. If there are small changes, that has to happen. So one of the techniques that I picked up with a colleague of mine when I worked for Equal Expert, Marco Vermillion, he's the core contributor, creator of SDKmon. What he would do is when the code was generated, as you'd review the code with a pair or with others, and then would drop a to-do in the code that says, hey, I don't want to do nested for loops here. I want to use streams to be able to do this. So drop a to-do in there, put that definition in there, and then you would have the LLM roll through there, pick up all the to-dos, and update the specification from that. Interesting technique. Tried that a few times. That is a useful way of doing it. I've done that. Other times, I will just make the change, because in my approach with spec first and the approach that we try to follow, the code is our source of truth, not the spec. The spec is used to help us get there, help us align on it, help us to do some of the thinking, and then just automate some of the code generation. But the code is actually the source of truth.
So as that code changes then, do you go back to update the spec, or the spec is kind of like a kind of old document at that stage?
It depends. You mean as we go on?
Yeah, as you go
past?
forward,
So right now we get rid of the spec. We drop the spec. I haven't completely excluded it from the code base, but I exclude it from what we ingest, because you don't want a mixed source of truth between the spec and then what's the code. The code is the source of truth. Okay. So we exclude the spec and what we analyze, but I think it's going to be completely moved very soon.
So the execution then just leaves you with pure code. Does it also execute? Does it generate any tests from there at all, or is that kind of more into the last?
This is what we were talking about before with spec-driven development, or with BDD. Like in many cases, one of our tasks would be to generate spec. And so what you've seen, I'm sure, is when you generate code and then you have a task afterward that says create 95% code coverage across this. What the LLM will do is take the code and create tests from that, which makes incredibly brittle code. It makes incredibly brittle tests. So what I then wound up doing as we go through this is I'm spending so much time trying to fix these very, very brittle tests that I wind up just get rid of the tests and regenerate them. That feels disingenuous. That doesn't feel right. So what we're doing right now is we're pushing tests into the specification. So during the planning process, part of the spec defines BDD. So when you're generating code, you're generating the spec, the tests that go with it. So it's together, it's not done as an after effect.
Which I think at Tesla as well, in our very early learnings, we originally had kind of like specs for capabilities and features, functionality essentially, and tests separate. And we kind of like realized, and we realized this pretty quick as well, capability is just a different way of describing a test, and a test actually describes a capability, so we kind of like merged it all together. And yeah, I think that's absolutely right. And yeah, I've seen similar examples of tests being written for code and for the absolute implementation of the code as is, and it makes it hard. It puts LLMs into that loop when it wants to make changes and things start breaking, and it chases its tail a little bit in terms of what it should change, whereas the test or the code and so forth.
What's interesting is the more you have these conversations, like you and I haven't specifically talked about that, but we're finding we are all converging on similar behaviors with specs and what goes into the specs and how they're created. I find that really interesting that people come from similar backgrounds and create a similar approach to this.
Yeah, I think it's good. The final R.
Final R. So this is actually something that I think we miss too much, and that's the QA, right? This is QC. Like, we've all established this pattern of plan and execute. You're seeing them brought into the IDEs like Cursor now. All that's there. Ripper expands that a little bit. And what it does is now verify the thing that was created match the specification. So in that review stage, what it does is it looks at the plan, looks at the code that was created, and shows you drift. Did it do what you asked it to do? And it pushes this back to the developer, and the developer can say, yes, I actually want that. That drift is okay. It does what I want because I'm reviewing and accepting it. In that case, we have to remediate it. But what it does is it verifies that the plan that was given is what was actually created, and then puts it in the hands of the developer to decide what to do.
And is that like LLM as a judge style? It identifies the drift based on what it's seeing versus actually running some test to validate?
Yeah, I mean, I haven't called LLM as a judge, but yes, it is a stage that says, given this plan and the code that was executed, what does it match it? And it has things like create a checklist, and so it'll give us our little green check marks that say it was all there, and red identifies the things that were mismatched. An interesting trick, an interesting feature of this, though, is sometimes you want that drift. Like, it actually is something that's beneficial. I say something in my talk that the reason why LLMs are so powerful is because they're non-deterministic. If it was a pure function, we've had them for a while. If we give it input, it gives us an exact output. It's called a template. We don't necessarily need a non-deterministic behavior from an LLM to achieve that. So sometimes it will give you something that you're like, oh, I like that. That's okay. So what in that case we'll do is use a review, get that drift, and then we'll identify that drift and tell it to go back and update the specification, so that way we can get it back and we remediate it that way.
For people who want to read more about this, do they go to, where's the best place? The ThoughtWorks blog or?
To be honest, we haven't blogged about it. This talk will be published in a few weeks. It'll be available. There'll be some things I'll put out on LinkedIn, and I'll get some posts out there. But I don't think there's anything I can point to other than the Cursor forum where I actually found it originally, which was March of.
But follow Wes on. Where's the best place?
Blue Sky. I'm on LinkedIn primarily. Don't really use X or Twitter as much these days, but I'm out there.
Amazing. Wes, it's been an absolute pleasure.
Thank you, Simon. I really appreciate you being at the talk, and I appreciate the opportunity to chat with you.
Thank you.